Hello everyone, welcome. Thank you for coming to Angular Lunch. This week we've got Cory Rylan, and he's going to be talking to us about reusable UIs with web components. If you haven't already found it, the pizza's already here, so make sure you go ahead and grab a slice before he gets started. And I also wanted to let everyone know about a little bit of news with the meetup. The STL Angular meetup. There was one of those in the evenings over in Clayton, and the person organizing that was Josh Godai. He's one of our instructors here. He also worked at Bullhorn full-time. And he actually recently asked us to take over organizing and running that one as well. And so if you're looking for an evening meetup or know someone that looks for an evening meetup for Angular, we're going to be hosting that one as well. We still have a lot of logistics to be determined, such as when and where we're going to have that. Traditionally, it was on the second Wednesday of every month. We're not quite sure how we're going to do it just yet, but if you're interested in that one, go ahead and look that up on Meetup. That one's the STL Angular Meetup was the name for that one. So go ahead and join that one if you're interested, and we'll send out some news through the member list there. So thanks for the little commercial, and everyone go ahead and give Cory a round of applause, and he can go ahead and get started.
Okay, so thank you for attending. My talk is about web components. How many people here attended DevUp? Because I see one t-shirt. Okay, a few. So if you attended my web component talk at DevUp, this might be a little bit of a review for you. So hopefully this is new for most people. So a little bit of background about me. I'm a GD for Angular Web Technologies. I'm a front-end developer for a small company here in St. Louis called Vintage Software. I also help with the Angular bootcamp classes. You can find more of my blogs and stuff like that at CoryRylan.com and my Twitter, CoryRylan. So what are web components? When I first started using web components, I kind of made this assumption that it was a single standardized API. Like I could open the Mozilla MDM docs and say, see the definition, what is a web component? It's like these things. It was actually kind of a collection of different APIs that you can pick and choose to create these web components, these little pieces of reusable user interface for my application. And each one of these APIs can be used individually. You don't have to use these with web components specifically. And each one has its own purpose and capabilities. But when you tie them all together, you get this really nice, compelling story of how we can build components that work pretty much everywhere. So there's a few reasons why we would want to consider web components. So there's a lot of frameworks out there that have a component model. And for the most part, all these frameworks have kind of converged on the component. They all look pretty much the same, work the same way. Really, it's starting to come down to syntax, kind of what template syntax do you prefer over another. With web components, it's just providing kind of a generic API that can work with any of these frameworks. So one of the big reasons we would want to consider web components for our application is since these features are built into the browser, they're going to tend to be fast. They're going to be built natively. We'll get really good lightweight performance because we have to send less JavaScript to the client because we can just use the primitives provided by the browser. Another big reason to consider web components is using features like ShadowDom, we can get some really nice CSS encapsulation features that the browser had lacked for many years. So with standard CSS, it's global. If I make a paragraph red, that's for the entire application or entire website. Using some of these features, we can make sure that only those styles affect certain pieces of our application or certain templates and components. And that's all built into the browser now. It's all native, so we don't have to add additional overhead of, say, CSS and JavaScript or some kind of pre-processing step. It's just built in. But the big reason I looked into web components is this idea of reusability, being able to write a component once and then drop that into several different frameworks or platforms. So most of these JavaScript frameworks now can use web components out of the box. So Angular specifically was designed, its template syntax was designed to be very interop supporting web components. Vue supports web components really seamlessly. React, sort of. You can use web components in React, but there's a little bit of workaround you have to get through. You can find kind of compatibility of all the different JavaScript frameworks by going to a website called Custom Elements Everywhere. Custom Elements is kind of the base API that you use to create your own web components. So defining that custom tag in your HTML is kind of the first API you really need. So this website does some kind of tests against each JavaScript framework and library to see how compatible they are with web components. If we scroll through here, most of them score 90 to 100. So latest Angular, Angular 6 has 100. Even AngularJS, older Angular 1.x, they recently updated like the 1.7.3 version, added web component support. So if you're coming from Angular 1 to Angular 2 plus, web components might be an option to kind of create an upgrade path by using these generic components. So most of these have pretty good scores. The outlier is React. This page does show open issues and what they plan to do to fix those compatibility issues. If you do want to use web components with React, you can follow these issues to find kind of a couple workarounds. Another option is Preact, which is kind of a smaller, lighter weight version of React. Very similar API, and it has a little bit better compatibility with web components as well. So the main reason we want web components is this ability to use everywhere. And this is really compelling for large teams and large companies that have several different projects running. This one's React, this one's Angular, this one's Vue, Ember. And we want to be able to share these things across these teams easily. So the browser support is getting pretty good. Right now, Chrome's been supporting custom elements for quite a while. Safari supports custom elements as well. It's kind of this yellow-orangish because it supports custom tags. There's one feature that it does not support. In web components, you can extend existing HTML elements. So for example, you want to add additional behavior to a button element. That is possible. That feature Safari doesn't support just yet. Firefox, the next version, will support custom elements, so we'll get a lot of the web component APIs built into Firefox, which leaves Edge and IE. Edge just recently, on their platform status tracker, just announced they are actively working on supporting custom elements in ShadowDom. So in the very near future, we should be able to get web components working in all the evergreen browsers without any polyfills or additional work. Now that does leave IE, so if you have IE 11 or lower support, there are polyfills, some additional JavaScript files you can include in your application to get these web components to work for IE. Okay, so I'm going to show some code, kind of show the basics of a web component with just vanilla JavaScript, so you can see just the web component APIs themselves. And then after we get through some of those demos, I'll show an example of that exact same component being used in an Angular CLI project and a Vue CLI project. So you can see the interopt and how that looks. So for my web component, I'm going to create a very simple kind of drop-down widget. So I've got this little button here. If I click it, it just shows some dynamic content. And I can swap this content out on the fly. So I'm just going to show how to build this little example here, because this little drop-down actually touches several different web component APIs. So the first thing to creating a web component is the custom elements API. So how do we tell the browser that we want to define a custom element tag to use in our HTML? So first I'm going to start with the index file here. So the index file for all these steps for the most part is going to be the same, not much is going to change. So our custom element is right here, this x-dropdown. So this is my web component. Now the reason I prefixed it with x and dash is for custom elements, the API recommends that you have at least one dash in the name. And this is going to protect you from accidentally using a name that could be used in a future version of HTML, so there's no naming conflict. And then I have one script tag here. We have type module, so I'm just going to use vanilla JavaScript, ES 2015 JavaScript built into the browser. So no build step, no Babel, TypeScript, or anything like that. So in my index file, I have a import. I'm going to import my web component. I'll get to the definition of that in a second. And then I have this document.query selector. So when you define a custom element in the browser, it's treated just like any other DOM element. So you can grab a reference to it and interact with that particular element. So looking at our dropdown, this is kind of the minimum amount of work you can do to get a custom element. Oops, losing my mic here. Okay. So to create our custom element, we extend the HTML element class. And then I'm using one of the custom element lifecycle hooks called connected callback. This is called whenever the element's been attached to the DOM. So once that's been attached to the DOM, I set the inner HTML of this element. So I'm just setting it to a string, hello from custom element. And then I need to register that element. So I just need to tell the browser, here's a custom element you should expect to see in the HTML, and attach this behavior to it. So using the custom elements API, this is just a global, it's on the window object. I call .define, I give it the tag name that I want to show up in the HTML, and then the class reference for my component. So if I go to the running example, we see hello from custom element, and if I inspect the DOM here, we get my X dropdown. So no fancy functionality, but this is just the minimum to get that custom element on the page. Now our second step introduces a new API, the HTML template API. So the HTML template API allows you to define a template tag. So it's kind of a newer HTML5 feature. The template tag allows you to define DOM in your HTML that's kind of inert. It won't actually render or execute any code. This is really helpful when you need to create chunks of DOM and render those at later points in time. We can use this to efficiently create templates in our web component. So many of the web component libraries and authoring tools that I'll cover a little bit later use this under the hood, and they kind of do this low-level wiring up for you. So this is all still very low-level APIs. So we're going to create our template. So document create element. I create my template object. I set the inner HTML with just a simple message. And then in my definition, I'm going to use the ShadowDom API. So the ShadowDom is what's going to give us some additional features such as CSS Encapsulation and a content slot API we'll see in our next step. So to create a shadow root on my element, I call a method this.attachShadow, and that I get that method from inheriting from the HTML element base class. And I pass some options into it. So this mode is mode open. There's a couple different options. I won't get into it too much. I'd say typically most web components use this open mode. It allows you to be able to modify things in the ShadowDom a little bit easier. So this will actually create this kind of chunk of isolated DOM that's protected from any global manipulation. And with that, I'll just assign it to a property on my class, so this.root. And then on my root ShadowDom, I'm going to append my template. So I'm just going to clone a copy of the template and attach it. So if I go to the running example, I have my component. For the most part, it looks the same, but looking at the dev tools, we can see now I have this shadow root element in the dev tool. So this is the feature that's going to give me all that encapsulation functionality. So still a little bit of kind of low-level wiring up to do this. But in our next step, using that ShadowDom API, we'll be able to actually add our kind of drop-down behavior. So our drop-down here, if I click this, we kind of get the dynamic content showing. And the way I do that, in my index file, I'm adding some content directly between the element tags. So this is a pretty common feature in most of the JavaScript component frameworks. So if you come from Angular, this would be ng content. And what this will allow is the component to take any content that you put between its tags and dynamically insert it into a specific part of your template. And this is just a nice API for developers to be able to kind of declaratively define content for their components. So to do this, we have to have a ShadowDom enabled for our component. So in my example, I have my template. I'd have a button for my dropdown. I have a div element, and now I have this slot element. So the slot element is what tells the browser, take that dynamic content and insert it at this point, line 5, in my template. So if I go back and look at my running example, we'll see that div with the slot element. Now notice when I inspect that slot element, we have this kind of text reveal, and then the content is kind of on the outside. It's not actually inside the slot. So it's kind of a content projection. So the content's still on the outside, but it's rendering here at the slot. Now the slot API has more advanced features. You can do multiple slots and name slots. So if you want to insert maybe dynamic content for a header of a card and maybe the body of a card and then the footer of a card, you can do things like that as well. And the slot API, you don't have to do anything else. If you've defined a ShadowDom template for your component, you get that for free. So going down to the rest of my component, to create that drop-down effect, I'm doing some kind of low-level DOM manipulation. So when I click the button, it's toggling the visibility of that div. So here on my root element, I do query selector div, so I just get a reference to the div element. I set the style display to none, so by default renders, hides the content. Then I select the button element and add a click event listener. And then whenever that click event fires, I just toggle the visibility. So this is kind of showing how web components are still fairly low level. This is kind of a lot of imperative wiring up code we have to do. Whereas if you were in React or Angular, this would be quite a bit simpler. It'd be less code. So big thing to remember is these are low-level APIs that other frameworks and libraries can take advantage of, and we'll cover those in a few. The next thing for components is usually for components we need some way to communicate with these components. For most JavaScript libraries, that's been through properties and events of some sort. I can pass data down to a component, and a component can emit events for me to listen to and get notified about updates. So for my drop-down example, say I want to be notified whenever the user has opened the drop-down. So the use case is maybe when the user opens the drop-down, I need to load some dynamic content into it. So it'd be nice if my drop-down had a custom event that would notify me when the drop-down has been opened. So with web components, that's fairly trivial. Here I have a custom event, dropdown.addEventListener. My custom event name is show, and then I'm just emitting the event value. So to define my custom event, go back to my dropdown. I still have my click event for my button that I defined in my previous step. I've just kind of moved the code down into a method, this .toggle, every time I click that. So the toggle method does the same thing, it just shows and hides the dynamic content. But now I have my custom event. So for custom elements, I call the dispatch event method that's just built onto the component. And then I create a new custom event. Custom event takes the name of the event you want for others to listen to, and then it takes a configuration object with any data that you may want to pass back. So here on my object, I have this detail, this.show. So I'm just returning true or false whether or not it's shown or hidden. So if I go to the running example, I go to the console here, you can see whenever I click that element, the event fires, I get the console log. Now when that fires, the custom elements API is going to return more than just the data that you pass through. So you can see it returns all the different DOM information about that particular element, just like a button would if you had clicked it and had an event listener on that. If we look closely, we can see our detail property. So the custom elements API is just going to take that object and merge it into the rest of the information about that elements event. So now that we know how a component can communicate to us by an event system, we need to be able to pass data down to that component. So to do that, we usually use something like properties. So for my example, my dropdown, I want to be able to configure the title of the button. So here it's custom title, and then a few seconds later changes to new custom title. So I want to be able to just tweak it and pass some information to it. So to do that, I'm going to use properties on my custom element. So for custom elements, you can find these properties on the object. And whenever one of these properties is set, your component can re-render and update that template. So just like before, I have my click event. But on my dropdown, I've defined a title property. So whenever I set that, my component's going to take that information and then update the inner HTML of my button element. So here I set it to custom title, and then just to show that you can trigger re-render, I have a set timeout, and after 3 seconds, I update the title again. Now, to define the property on a custom element, it can be very verbose depending on how you do it. And this is where the tooling for web components will come in handy. But if you're doing just the vanilla API, to define a custom property, we can create a get and set for our title property. And we'll have a private title for the hold on the internal state. So I have the underscore convention in JavaScript. So whenever I get the title, I'll return the private value. And whenever I set the title, I'll set the internal value, and then I update the inner text of my button. So anytime that property is set, because it's just a JavaScript setter, it'll just automatically execute this code for me, which just updates my DOM. So it's still kind of verbose to define custom properties. If you come from Angular, this would be similar to your input decorator. Angular is kind of doing something very similar behind the scenes, but this is kind of the low-level way of doing it. But with this, we can now pass data down to these components. We can pass any data type. These are just JavaScript properties on an object. So we can pass arrays or objects or arrays of objects. It doesn't care. It's completely content with any data form. Now there's one other way you can pass data to a web component. You can use attributes. This is more of a convenience. So on my X dropdown here, I have a title attribute. So I want to just pass a string of information to that component. So it's a little bit easier than having to select the element and then set the property in JavaScript. I can just declaratively pass some information onto it. Now the trade-off with attributes is because we're in HTML, anything you pass into the title is going to be a string. So you're restricted to just string types. If you were to say pass a number, it's going to be a string of 6. So if you want to enable that, you'll have to do some like parse int on the other side. So it's kind of a trade-off, a little bit more convenient, but you're restricted to strings. Now to enable attributes, there's 2 steps. The first step is you have to tell the component which attributes you want the component to be looking for changes. This is more of a required performance optimization. Attributes tend to change a lot, especially if it's inside of a JavaScript framework. It's updating attributes quite frequently. So the component requires you to explicitly say which attributes on this component you want to be looking for. So for ours, it's title. To listen for whenever that attribute changes, we listen to a lifecycle hook called attribute ChangeCallback. This would be very kind of similar to ng on changes if you come from Angular, a little bit different, but similar concept. So whenever that attribute changes, this method will get called and pass in 3 parameters: the name of the attribute that changed, the previous value, and the new value. And that can let you do some optimization. So if the attribute is title and the old does not equal the new, then go ahead and update the actual title. So we can make a little bit more optimization of when these DOM updates occur. Our next step introduces the CSS encapsulation that I've mentioned a few times. So we've been using ShadowDom. We used the slot API, which was really convenient. But the big thing with ShadowDom is this CSS encapsulation. So in this version of my dropdown, in my index file, I have a global style tag that says all divs should have text color red and has a little bit of margin on it. Now if I open my dropdown, which also has a div, we notice the text color is not red. So because I'm using that ShadowDom feature, that global style does not override my component specific style. And in my component, if I look at the computed styles here, my component has its own custom styles. So I define some padding, a gray border, and a width. And that is just on a div selector. So my component styles and its gray border are not affecting the global elements either. So it's kind of this black box. Styles don't leak in, styles don't leak out. So it's a really nice feature to have on large teams with a lot of components. Now to enable this, if you just declare a ShadowDom reference in your component, you get it for free. So here's my global style. On my index file, I have my dropdown component. If I go to my dropdown component in my template, I have a style tag with some styles for that particular template. And then I have my ShadowDom declaration just as normal. So it automatically encapsulates that. Now, the downside to this API right now is, you notice I have this kind of big chunk of string that I'm having to deal with. So I have CSS kind of inlined here. A lot of the web component authoring tools provide tooling that allows you to write your CSS in CSS files or Sass or less, and it can compile and inject that for you. So you get the nice editor support of a CSS file or Sass features, but it will give you that encapsulation feature as well. So the tooling is really important for the web component ecosystem. Now with the ShadowDom, there's kind of an issue we run into fairly quick once we start working with it. This is great that it encapsulates the styles, but what if I want to customize the component styles? So I'm using your dropdown component, solves all my needs. I think it's great. I think it's kind of ugly though, and I want to just tweak it a little bit. So with ShadowDom by default, it's not really easy to just override those styles. It's designed to not let you override the styles. So to fix that, we can use a new CSS feature called CSS Custom Properties. So once again, this is just another API that can make it easier to define these components, but it's not really specific to just web components. So CSS Custom Properties allows us to define properties on our component that are publicly visible for other developers to adjust the styles of that template. So for my use case, on my dropdown, I want to be able to allow developers to override and change the border color of that particular component. So to do that, using the Custom Properties API, I can define my own property. And the syntax for this is a little weird. The way we define a custom property is we used a selector called the host selector. And this selector just says, basically, select the element of my host. So that would be the actual X dropdown tag. And define a custom property called border color. So all custom CSS properties are prefixed with 2 dashes. It's just a syntax requirement. So now I have this property. And these custom properties in CSS work a lot like variables in Sass or less. You can redeclare these elsewhere in your CSS. So down in my div, I have my border, and I can pass that custom property to a CSS var keyword, variable, And now I can use that gray border applied to this particular div. So it's like a Sass variable in a sense. But because I defined that variable on my host element, that means anyone using this component can override that border cover property for me. So there's kind of two features using custom properties. I get variable functionality that I'm used to in Sass or less, but I also can get this API to customize components. So if I go to my global styles, I can select my component and then override that custom property because it was exposed by the developer who wrote this component. So now if I save this, and we go back and open it, my border is red. So using custom properties, you can actually create kind of a theming API for your components. And this is really important for like large teams with a lot of different products. They want design consistency between products and between applications, but they do want to be able to give teams some flexibility in how things look. So using custom properties in ShadowDom, you can prevent them from doing kind of crazy changes, but you can give them exposed particular APIs to tweak the styles. So all those were kind of a quick summary of a lot of the basic low-level APIs to create a web component. But to create web components in a production environment, it's going to take some additional tooling, things like polyfills for browser support. And as you saw in our examples, we were dealing with a lot of low-level APIs for manipulating the DOM. And that's kind of why we chose Angular and React in the first place. We didn't want to do that all day. So a lot of the frameworks, JavaScript frameworks, are supporting web components. So Angular Elements is a project from the Angular team. The idea is you write your Angular components, and it compiles out to a vanilla web component in a sense. So you can use all the nice Angular framework features, but get the ability to use that component anywhere across your team. Another project that's been around for quite a while is Polymer from Google. They've been doing web components since the beginning. They have a new project called Lit HTML. Kind of a new templating syntax, so you can get some nice vanilla JavaScript templating similar to React without any build step. Another project to look into is Stencil.js. So if anyone's used Ionic for their mobile app development, Ionic components in their latest version are actually all web components. So they're using web components to be able to create mobile native apps. And they built Stencil to be able to do that. And I'll show a little code snippet of Stencil code and what that looks like. And then the last one, this one I have the least experience on. Just doing some research, it looks like the Vue community has a library called Vue Component Wrapper that lets you create a Vue component and then wrap it in a custom element. That way you can take your Vue components and use them anywhere you want. So using these tools, you get the benefits of these high-level APIs, really nice declarative syntax that we enjoy from frameworks. But in the end, it's just a web component on the other side. So we get all the benefits of web components. Okay, so show a couple more quick demos before I wrap up. So I'm going to show that Dropdown component in an Angular app and a Vue app, and just show how they integrate seamlessly. Okay, so to use a web component in Angular, I've got a Angular CLI project. This is running Angular 6, I believe. The first step is you'll need to publish that component in some fashion, whether that's through NPM or a private repository or monorepo. You could go several different ways, but having some way to distribute that component to your teams. My example, I've just published the dropdown to NPM and installed it through my package.json. So once you have your component installed from wherever you published it, in Angular, it's kind of a two-step process. The first step will be to import your component into your Angular application. So I published this dropdown at this npm package web component essentials, where I've been publishing a lot of test demos, web components. So I import my component. And then for Angular, I also need to import this custom element schema here on line 2 and add that to my ng module. So Angular does a lot of static checking of your templates to make sure you don't have things like typos, like you mistyped a component name, to catch those kind of errors. Because of that, it needs to know when there are custom elements that are not Angular components. It just needs to be aware that those custom tags exist, so it doesn't throw errors saying it doesn't know what this element is. So this just tells the framework, hey, we're using custom elements in our templates. Mm-hmm.
Will that just detect, kind of whitelist those custom elements, or does that break your checking for all other like typos?
From what I've seen, it disables that particular check. So if you do make the typo, now it's not going to catch it.
Okay.
So it's kind of a trade-off here. So I'm hoping maybe that part of the API improves where you can explicitly define what custom elements you're using. That way you can get the best of both worlds.
Mm-hmm.
Unless someone else knows any other workarounds. I haven't seen anything yet. So it's an unfortunate trade-off.
We're all still waiting for them to do something with that schema capability.
Yeah.
The same way it's like, we'll just like throw the doors wide open because I'm using one custom element.
Mm-hmm.
It's clearly a very poor design,
Yeah.
but that's all we have.
Yeah, it's kind of a trade-off you have to swallow if you want to be able to use the custom elements, is you lose that check. And that's bitten me before. Like, I have an application where we need to use custom elements. Got a lot of productivity out of it because we could use it across several different apps. But then we lose that check and we've made typo mistakes and the build didn't catch those. So I'm hoping this API can be kind of expanded on in the future.
Yeah, or like toggle or something.
Mm-hmm. You can, if I remember correctly, I just learned this last week. I believe if you define that custom element schema to locally where the module that is using that component, it will only disable that check for that particular module. So here, I believe this would be application wide, but say like only one feature is using a custom element, you could apply it to just that feature module, and it would just disable that check for that particular module. I ran into that last week. I'm pretty sure that's the behavior. I'm not 100% sure, so that's something to try out. But once you've imported your component from your package, you've added the custom schema, then you can just start using it in your Angular template. And what's really nice about Angular templating syntax is they kind of had custom elements in mind when they built it. So from this perspective in my template, that looks like an Angular component to me. I don't really know the difference. If I want to set the title property, I use the property binding syntax Angular defines. So I have a my title property on my Angular component in my TypeScript here. It's just a string project Angular. And then I can assign that to the title property of my dropdown, just using that binding syntax. If I want to listen to my custom event of my dropdown, I just use the event binding syntax from Angular. So I listen to the show event, and I can call a method on my my Angular component. So if I go to the running example, you can see we have an Angular application. We can see we have the exact same Dropdown web component, just working just like any other Angular component. Okay, so then the next step is a Vue project. So this I built with the Vue CLI. And the Vue project wasn't much different. I installed the package through npm. I imported it into my Vue application. And then in my Vue.js component, I can just start using my custom element. So Vue.js, this looks very similar to the Angular example, similar syntax. They have a very similar syntax to Angular. You can bind to properties. Instead of square braces in Angular, they use a colon shorthand syntax. And then instead of the parentheses in Angular for events, they have an @ symbol. So exact same mechanism. I can bind to properties on components, and I can listen to events on components. So this is what kind of sold me on web components, is I was able to build this generic component that actually worked in different JavaScript frameworks. I didn't have to worry about compatibility. It just built into the browser. So if you have like a UI component library kit that you have to maintain for different teams, different projects, web components are a really compelling reason to use because you get this kind of built-in functionality. So one last bit of code I wanted to show is just kind of what one of these component library authoring tools would look like. So this is the same drop-down component, but written with Stencil.js. So this is Ionix tool for writing web components. And it's kind of an interesting tool. It's kind of a hybrid between Angular and React in a way. They use TypeScript and decorators, so this is going to look very similar to Angular. We have a component decorator with some properties. We're using TypeScript and classes. But then they use JSX templates. So if you come from React, this JSX is going to look very similar. And what this allows us to do is kind of get these nicer high-level APIs. So we can declaratively create a property or an event with very little code. We get the nice benefits of JSX templates. But in the end, this just compiles out to a vanilla web component. So we can get the benefits of a framework, portability of a web component. So Stencil would be one of the top choices I would take a look at if you're looking into web components. So one thing I'm working on, I'm trying to gather up resources about web components I'm putting together at webcomponentessentials.com. I've got some blog posts and videos, and I'm working on an ebook. So if you want just some more information about web components, I'm trying to get more stuff put together. So you can check that out there. But that is everything I have. So thank you for attending. Yes, time for questions.
Do you know how much Angular is implementing features to take more advantage of this? You can kind of see how you could almost build an Angular using this. But I didn't know if they're re-implementing features and if we could expect like a performance improvements from that, or if you have any idea.
I know a little bit. So the big focus of the Angular team right now is their Project Ivy, which is kind of a big rewrite of their rendering. That's going to give a lot of performance improvements, lot smaller JavaScript bundle sizes, just optimizing the Angular compiler. That's the main priority. That will likely be in version 8, won't be in version 7 that's coming out soon. That new Ivy compiler is going to enable Angular to compile much smaller Angular components, which is their goal for the Angular Elements project. So the Angular Elements project was write an Angular component and spit out a web component for the compatibility. So they're trying to get Angular more performant, get those bundle sizes as small as possible. That way when you drop an Angular component inside of a different application, it's not pulling in a bunch of Angular. It's just a little itty bitty bit, just what's necessary for that component to function. So the Ivy project and Angular Elements, those two projects have similar goals. And both of them, whether or not you use web components, you're going to get huge performance benefits by just using Angular. And then if you do decide you want to write custom elements or web components with Angular Elements project, you should also see some big performance benefits as well. Both of those projects are still a work in progress, so I wouldn't say they're production ready just yet.
With the ShadowDom, obviously in your example it was the case where everything was isolated, but can you actually flip it the other way and actually say, you know, I actually do want to use what, you know, like the font or whatever that's declared outside of my web component?
Like apply this global font to like just this particular component?
Yeah, like if you had like just a real simple button and you actually did want to have it inherit the outside styles.
Don't use ShadowDom, right?
Yeah, so yeah, you have a couple options. You can just turn off ShadowDom, but then you lose all the encapsulation. Sometimes you want the encapsulation, but then like apply just one of these global styles.
Okay,
to the component.
so you could do it and just not do ShadowDom at all.
Yeah,
then.
that's one
Okay.
option. Another option is, and I've kind of run into this, is I want encapsulation, but I want one of those styles to apply. So the way I did that, there might be a better way, is I was using Sass for the components, and I had like a mix-in type thing, so I could globally apply a class with that mix-in, and then my web component Sass file could just pull that mix-in in and apply it to that specific component.
Okay.
So kind of a workaround, but it's possible.
I don't know if I'm your hardball or softball questions, but the web component stuff you showed us looks pretty similar to like how we make components with Angular and React and Vue and so on. Like, are there some cases where you might use web components, stencil, whatever, instead of Angular or React, as opposed to as another layer?
Yeah, I think there's a lot of use cases for just using web components. The kind of the obvious use cases would be if you're building out a UI library for multiple teams to use, you would want to just start with web components to get that reusability. If you were needing to integrate components into existing applications, so common use case I see is I have a traditional server-side website, so it's using .NET MVC or something like that, and I just want to add a little bit of functionality on top of a static page. Well, Angular itself is really designed for single-page apps, so like trying to pull in Angular into like an existing MVC site would be pretty painful. So web component would be a good use case for that, is I can just create a component and drop it in to my static HTML my server produces and get that functionality. I think there is also an argument that you could build full-on single-page apps with just web components. There's going to be some trade-offs. So like the benefits is you can get some performance and you're not relying on a framework. The trade-offs though is you have to make a lot of decisions for yourself. So this looks very similar to React and Angular, but then when you get into the details, you realize you're still missing a lot. So like, how do I handle forms? Like Angular has a great forms API. But if you go pure web components, that's on you. How do I handle routing? Because now I'm not using the Angular router, so I need to go find a web component router. And those things exist, and some of them are really good, but now it's up to you to go find those pieces and kind of stitch it together.
So it looks like React is quite a bit behind Vue and Angular in this regard.
Mm-hmm.
Is this something that they're actively working towards, or has it been just like accidental that there's been some sort of partial support? Like, do they actually have any kind of plan in place for this, or is it just kind of a afterthought in the React community?
I'm not sure on how motivated they are to update those APIs. I looked through some of those issues, and there are several proposals of how they would add full support for web components. Unfortunately, it looks like to make those changes would be breaking changes for React, and they're very hesitant to make breaking changes. If they can try to avoid it. I think it's not a super high priority right now for React and their ecosystem. So I could see in the possible future they will eventually get there. I think it just might take some more time. And from what I've seen, the people who need to use web components in React, the workarounds aren't that terrible. Like the most common workaround is like I need to use a date picker that's a web component in my React app. The easiest way is I just make a very thin wrapper component around it. So I just create a really thin React date picker component that just interacts with the web component directly. And then the rest of my application just thinks, oh, that's just another React component I'm using. So hopefully it'll improve, but I'm not too sure how quickly that might be. So my hopeful prediction, optimistic prediction is frameworks will continue to leverage web components more and more. And in the future, a JavaScript framework isn't about the component. It's more of the tooling gives you around that. So like Angular is like, we give you a great router. We give you great forms APIs. We give you a lot of testing tools. And then we just leverage what's already there with web components.
there anything in web components to make surface calls, or would you still do that in the Angular side and pass it down to the web component?
There's not anything built in. You would probably, majority of the use cases for web components, like in a generic sense, is you want them to be kind of pure components, like they're just properties and events, like they don't have direct access to the data source. You could use services, possibly. I'm not quite sure how that would work. I'd have to play around with it. But there's no built-in way that I know of. Okay. All right, no other questions? So thank you.